Hello children, we have been studying about chapter 3 understanding quadrilaterals of standard 8. Now we are near the end of the chapter. We have already studied about various properties of different types of quadrilaterals. Now we are going to use it and we are going to work on exercise 3.4. Question number 1, state whether true or false. All rectangles are squares. It is a false statement. If you have been given a rectangle, you cannot call it a square because in square all sides are equal, whereas in rectangle it is not. The next one, all rhombuses are parallelograms. It is a true statement because the properties of parallelograms, they fit into the properties of rhombus. All squares are rhombuses and also rectangles. That actually means the properties of rhombus and rectangles taken together makes a square. It is a very true statement. If you think of all the properties of rhombus and rectangles together, you will see that each and every property holds true for a square. That is why this statement is a true statement. The next one, all squares are not parallelogram. Absolutely false statement because every square is actually a parallelogram. Square is a special type of parallelogram. Next, all kites are rhombuses. False. The property of rhombus is all sides are equal, wherein in a kite, all sides are not at all equal. The next, all rhombuses are kites. Yes, this statement is true because the properties which are of kites easily fit into the properties of rhombuses, though rhombus has some more properties. That is why all rhombuses can be said to be a kite. All parallelograms are trapezium. True, because in a trapezium, one pair of opposite sides are parallel, whereas in parallelogram, both opposite sides are parallel. So the properties of trapezium easily fit into the properties of parallelogram. That is why the statement is true. Next, all squares are trapezium. Yes, because in a trapezium, one pair of opposite sides, they are always parallel. Question 2. Identify all the quadrilaterals that have four sides of equal length. So they are rhombus and square. In these two figures, all four sides are equal. Four right angles. Yes, they are square and rectangle. All the angles are equal, that is right angle, that is 90 degrees. Explain how a square is a quadrilateral. Now a square has four sides, it's a four-sided polygon, so it can be called as a quadrilateral. We have to explain now how a square is called a parallelogram. Because all the properties of a parallelogram wherein opposite sides are parallel, it fits into the property of a square. A square can be called as a rhombus. Yes, because in square all sides are equal. The same is true for a rhombus. Moreover, the diagonals also bisect each other at right angles in both. Now, how a square can be called as a rectangle? So, in a square, all angles are right angles. The same is true for a rectangle. So, a square becomes a rectangle. It is a special rectangle. Name the quadrilateral whose diagonals bisect each other. They are rhombus, parallelogram, rectangle and square. In all the four figures, the diagonals are bisecting each other. The diagonals are perpendicular bisector of each other. This is true for rhombus and square. So it can be a rhombus or a square. In both the figures, they are perpendicular also. The diagonals are perpendicular also. They are equal. The diagonals are equal. This is true for a rectangle, a square, and an isosceles trapezium also. Explain why a rectangle is a convex quadrilateral. Now, a convex quadrilateral is a one wherein the angle, any of the angle will not be a reflex angle and the diagonals lie inside the figure. So that is true for a rectangle. So a rectangle can be called as a convex quadrilateral. In a rectangle, all angles are 90 degrees. That means no angle is a reflex angle. Moreover, if we draw the diagonals, both the diagonals are inside. So again, it is a convex quadrilateral. Let's proceed to question number 6. And this is the last question rather. ABC is a right angle triangle and O is a midpoint of side opposite to right angle. So this is right angle triangle ABC. It is right angled at B that we can see in the figure, and O is taken as the midpoint of the side which is opposite to right angle, that is AC. It is opposite to right angle B, and we have taken the point O over there, which is nothing but the midpoint of AC. Now the question is, explain why O is equidistant from A, B and C. We have to find out how come O is at equal distance from A, B and C. That means if I join OB, then I have to prove that OA equal to OB equal to OC. This is what is the meaning of being equidistant. Now we have done one construction. We have drawn a parallel to BC and then a parallel to AB, and these two parallels are joining at a point which we have named as D. Let us repeat this step: a parallel to BC, a parallel to AB, intersecting at the point D. Now if we talk of this figure ABCD, it becomes a rectangle because angle B is already told to be 90 degrees, and that is why ABCD comes out to be a rectangle. Now we have joined BD also, so we have both the diagonals of the rectangle. Now this is the construction which we have just now discussed. Moreover, now as this we have proven it to be a rectangle, we can easily say that AC is equal to BD because according to the property of a rectangle, the diagonals are equal. Moreover, we can say that OA is equal to OC is half of AC. The property goes as the diagonals bisect each other. The diagonals are equal as well as bisectors. That is why the halves OC and OA are half of AC. Similarly, OB and OD are half of BD. But AC and BD are equal, therefore all the four parts, that is OA, OB, OC and OD also will be equal. That is why we can say that O is equal distance from A, B and C. That is, O is equidistant from A, B and C. This is how we come to the end of the topic, that is understanding quadrilaterals. We'll start with something new in the coming videos. That is how we come to the end of one chapter. Thank you. Keep learning.